All right, guys, so we're moving into a part of the chapter where we're going to talk about um, solving square roots, or working with square roots, rather. We're going to be solving these quadratics, but we're going to be using square roots. So this is something that really pops up because not everything we do is factorable. Not everything we do is factorable. So what I mean by that is we're going to start seeing stuff like this, okay? Where, if it'll let me zoom in here, there we go. Right? If I switched this to be in the standard form of a quadratic, like if I took this and I subtracted 7 from both sides, think about it like this. This is something I can't factor, so I need to find other ways to solve. So when we're in this situation where n squared equals 7, how do we undo this? What's the opposite of squaring something? Well, the opposite is taking a square root. When we take the square root of something, it's very important that we remember that that results in two answers, a positive and a negative answer. Right? The most traditional example I think of this is the idea of like, okay, well, what's the square root of 4? Well, it's 2 or it's negative 2, because a negative times a negative is also a positive. So once we move in to these types of problems, we need to keep our head on a swivel for this. Okay, when we give our answers, we gotta be thinking to ourselves, there should be 2 of these. There should be 2 of these. Right? In addition to being able to keep that in mind when we solve these problems, there's some other rules that we're going to need to keep in mind as well. The first is this. If you have the square root of some large number, you can factor it. You can split it into its factors. And this is important because I'm going to ask you guys in this class not to take something like the square root of 16 and just put it in your calculator. You can get some decimal answer, some irrational number that forces you to round. I would rather have you do something like this. And when we do this, what I'd love to split this into is into having one piece that's a perfect square. Let's think about what some of our perfect squares are. 1 squared is 1. 2 squared is 4. 3 squared is 9. 4 squared is 16. This list of perfect squares, I have students that every time they take an assessment, they will write the list of perfect squares at the top of their quiz. And I go, it's a pretty good idea. That's a pretty good idea. So there's our first 10 perfect squares right there. So when you look at something like this, okay, the square root of 216, what I'm asking you to do is say, can you find a perfect square in that list here that is a factor? So originally I think, okay, 216, maybe 16 will work. 216 divided by 16, no, I get 13.5. We need to get comfortable with sometimes we'll hit a dead end. It's up to you to sort of keep going until you strike gold. So for me, I'm going to strike gold at 36. The 216 divided by 36 is 6. So I can split this into the square root of 36 and the square root of 6. And now we see why I'm looking for one of these. Because what is the square root of 36? It is 6. So I can write this simplified version of the radical, and that can be my answer. And my favorite example to sort of use when I'm teaching this is the square root of 50, because it's a good example of how, 50, you might be like, oh, I got this, Mr. Card. It's 10 and 5. And I'd say you're not really wrong. Like that is mathematically true. The square root of 5 times the square root of 10 is the square root of 50. It's just that this doesn't help me because 10 and 5 are not perfect squares. You know what would help me though? 25 and 2. Those also multiply to 50, but 25 is actually a perfect square, so I can simplify this to 5. And so that's what we want to be thinking about. All right. So that's one rule right here. Another rule that I want us to be thinking about, let me see if I can find a good example of it. I'll make up a good example of it. Because the other thing I want us making sure we can do is taking the square root of something when we have a fraction. So something like, if Mr. Card tells you, hey, x squared equals 1 over 4, you're going to wind up taking the square root of both sides. And when you take the square root of both sides, this is where our other rule comes in. So we have a rule for multiplication, we have a rule for division. That rule is that when you have a over b like this, you can simplify it to the square root of the numerator over the square root of the denominator. And that's pretty important to be able to do, right? It's pretty important right here because I can say, oh, this is really just the square root of 1 over the square root of 4, which is 1 over 2. And of course, I got to remember positive or negative. I have two options. All right, so those are some of the rules that we're covering in our first day of talking about radicals. We will have more to discuss as these things get more complicated tomorrow.